So now by now you understand all these properties. I don't have to, you all become Bayesian already, so you don't have to, I don't have to go through these slides. Maybe you just take this last control polygon, which by now you should be able to easily draw the Bezier curve. So can you just try out for the last guy, the rightmost with 4 points. So what would be the curve for this? All others I think you should be able to draw fairly easily, right? Okay, there is one more question which I will typically ask for my students only in the exam. Let me see whether you are able to crack it. So you should note that the Bezier curve passes through only the first and last point, not in any other point. So you redraw again. That is the point that you may have. But also you remember the curve follows the control polygon closely. So that point you have not taken it out there. You have taken, but I think you are in the wrong direction. Like for example, you try something here that we did, right? So when we travel the control polygon closely, but here also this is the control polygon locally, and we tracked locally that curve how it is. So if you do that, so how do you change that curve now? Okay, everybody is coming up with this. Oh, so can you guys think little bit better on what this aspect that I said currently? It does follow the control polygon closely, but like not exactly the way that we discussed in this case. So you think about that. So it is following, but this won't be the thing case. Yeah, so something like this. Yeah, go above. So that is why I said it follows the control polygon. So you have followed the control polygon in some parts. So if you think deeply, in the middle part you did not exactly follow the control polygon. I mean you have done, but kind of an outward direction on that. No, you had a little bit work on that. Imagine this guy. So you redraw this curve for this control polygon, that 5 point, and then observe what is that we did, and then translate it again onto that question. Some of the people have done this. You have to make some changes, so think about it. I think all of you are making a mistake somewhere in the middle. Which one? No, I think you redraw that other case that we just discussed and think it over a little bit. You are right, you are kind of following. I am not saying that you are not, but you could do better. Where is your control polygon? So unless you draw that, I cannot see. Bezier guy, needs a control polygon. Yeah, correct. It's the green, not the red. Okay, not the red guy. Yeah, red is a great possibility. I think many of you guys have drawn what he has drawn in red. Of course, I only know what he has drawn, but I think that I see in a lot of other guys' notebook also. But you could do little better if you little bit think more on that. So this part you have to little bit do better. I know that you have followed it, but you have followed something like this. It goes little bit for. So when you follow this here locally, that means that this is the polygon, so it should follow the. So I cannot go here and then suddenly come down. So when I go up here, so it will cross this guy and then it will go the other side. That is kind of more closely following that, right? So that middle portion is what all of you are going. I hope I am correct in that answer. So this is a course I taught long back technically. I think 2011 or 2012 is the last one that I taught this as a full course. But I like this, huh? Yeah, okay. Yeah, I didn't realize that. Yeah, it has been a decade that I handled this as a full course. It's difficult for me to figure out the color. Give me the notebook. Yeah, so if the shape could be similar to green. Shape is similar to green, but the color is what you are right. But color you have put something as a parabola. See, remember when you draw the curve more and more, you can see that the inflection point kind of thing also comes into picture. Not necessarily, but when you have a control polygon. So all of you guys are able to understand. So this is okay. This is you have overdrawn. Okay, there won't be any self intersection here. Remember, self intersection is possible as far as I know only when the control polygon has a self intersection. Barring that, I don't think it is possible. So for all of you guys, I think many of you guys are okay. Some of you guys I have to now reduce you to a 60% Bezier maybe or 70% Bezier. So it has now reduced. So as the control polygon is more becoming more complex, then it becomes, where is my thing? Okay, I have to draw it again. Okay, so if I have a thing like this, so it follows, that means what, it will be something like this, but many of you have drawn something like this, right, which also kind of follows. I am not denying that it kind of follows, but a more close following is perhaps something like this, right. So that middle part where many of you have gone wrong, and I think many of you have come up with the following shape, something like this. It's also of course not a bad one, it does have all the properties, but you can see that it will probably has lesser oscillation than what your control polygon has. So that point is probably not getting exactly fixed there, but you can see that the red curve is what actually will be the kind of Bezier guy, let us say 90% Bezier or something like that. So you can try more complex shapes on the control polygon. Now I am going to give you a tricky case. So hopefully, is the tea coffee ready, boss? 10 minutes. I am already running out. So so okay, take 3 control points, draw them currently. Take B0, B1, B2. What is your usual drawing? It will be a triangle, which is by now you have become expert in drawing Bezier curve for that. So it passes through only B0 and B2, but not B1, correct? We imagine. Now I am going to ask you a question. You put these 3 points as collinear, B0, B1 and B2. So what will be the Bezier curve? All are sure? But you only said it won't pass through B1. That it has to pass through. So kind of, well, if you just little bit lift it, what will happen? Whether the curve will pass through B1? No, right? So since this collinear is a special case, but the more trickier one, you flip the order. Same collinear 3 points B0, B1 and B2. I say first is B0, second is B2 and third is B1. Are you understanding this question? First is B0, your usual case, second point, that's middle point between your, let us say, so to speak, not necessarily middle. So B1 lies between B0 and B2 in your current case. So you just flip that. First is B0, second is B2, okay, and third is B1. Now can you tell me how the Bezier curve will look? Okay, kind of could do better, you are on target. But what is the convex hull between B0, B1 and B2? All are in the same line, it is a collinear line. So what will be the convex hull? What will be the convex hull? That line itself. So there is no way you can draw a curve out of that line. Are you able to see that? But then what could be the shape finally? B0 to B2, because it has to pass through B0, it has to pass through B2. Yeah, but then B1 doesn't even play a role. No? Okay, I will give you one more exercise on this one. Okay, do the same thing, but not 3 all collinear. So use a B0, B1, B2 first in a regular position and draw the Bezier curve, and then you flip. Okay, B0, the second point is B1, or the last instead of B2 make that as B1 and then put this other thing as B2. You are able to understand what I am saying? I am doing a lot of hand waving, but it is not very difficult to understand. So this is B0, this is B1 and this is B2. So draw what is your output curve. So what I am saying is that same 3 points in that configuration, okay, this is B0, So instead of and this is B1 and this is B2. Remember it, the control polygon is going to change and then the curve is going to change. Right. So what will be the curve in the first case and what will be the curve in the second case? So first draw that and then answer the other question. So how will the curve for these two control polygons? Okay, now you answer the other question. That's why I asked you to work out this control polygons. This and then come back. Correct. Same thing. You have to go out and come back. Same thing. It's always going to be on the same line. How much? See, will it touch B1? No. Somewhere near. We don't know how much near because that will come from your mathematics part of it. Yes. So you don't go to B1. It will go somewhere here and then come back. See, something like what happens? Something like flattening out of this curve. Okay. You are just punching the curve from lying as a regular non-collinear guy becomes a curve. You just kind of tap it. So that B2 guy you push it onto B0 and B1 lying between B0 and B1. Now you can see how this curve like this will go like this and become as, right? Are you able to, all of you guys are able to, or should I explain? So will it pass through B0 and B2? Yes. But will it pass through B1? No. So where it will stop? Is it going to be out of that collinear one? No. Okay. So you can come up with the answer from this curve, where you can see that I am going to have a curve like this. I clearly know that it will pass through B0 and B2. Will it be like this? No, right? By now, you know, you can see that it will be something like this. Now, what is the other case? So you can imagine that I am projecting this guy. So this is B0 and this is B1 and this is B2. Now, how will the curve look like? So it will start from B0. Okay, technically, that is, of course, that's even more interesting. So it goes, maybe I should use a different color. So I start with B0 and I have to stay on the same line. I don't have much choice on that. Okay. But it appears to go to B2 first. But what actually happens? So you remember there is a parametric thing also which we have never discussed. So if you have a t equal to 0 to 1, okay, it varies along the curve t equal to 0 to 1 as you progress on the curve. Okay, so B0 will have t equals 0 and B2 will have t equals 1. Okay, that is the underlying mathematics of it. So essentially it goes all the way to some extent. It doesn't go through B2. You can see that you will compress this guy, flatten this curve out. So and then you come back and then land it at B2. Which is essentially the same behavior as you have here. You go here and then, so this guy gets flattened it out somewhere here on. So it doesn't pass through B2 first. It passes through B2 later on the parametric value sense. So what will be parametric value when at B2? What will be value for t? What will be parameter value for t at B2? B2 will be 1. But what about the parametric value somewhere after B2? So the curve goes and comes back. So this is a starting t equals 0. It goes somewhere, maybe some value of let's say 0.8 or something like that, and then comes back, and this is 1. Though we draw something like this, it doesn't touch B2 first. Okay, it only touches, it gives the impression, of course, it does pass through B2, but parametrically it doesn't pass through B2 first. It only comes back and lands on that B2 last. So the value of the parameter there is actually you can see the t, but of course in this case it is a multiple case where there is some other parameter also takes the value of B2. You can see that thing. So are you able to get any satisfactory answers to this question? So if anybody thinks that is Jambavan of Bezier, You just ask this question. I am 100% sure that guy will go for it. He will basically draw the B0 to B2. So if you imagine how the control points were there when it is not collinear and how the curve was when the points were not collinear, and you just flatten it or project it, and you can see that it starts from B0, goes towards B1 and then comes back to B2 and does not touch B1, because that is the property of the B0. Okay. So, maybe I do not think I will probably be able to go more. I need some coffee or tea now. Any questions you have, guys? What are? So suppose if you, okay, we will just extend that question to curve itself. Okay. Suppose you have another control point in the same thing, and let us say B0, B0, B1, B2, B3. Okay. So this B0 is also B3. What will be the control polygon here? So the control polygon will have this. So this is the control polygon. Now the control polygon is closed. So how will the Bezier curve be here? Yeah, so you can see it's a oval shape, but then it's kind of it's not a fully smooth oval, not like this. Okay, you can see that it goes. You can see the tangent properties are, so this is also closed, but what is the problem here? So what is the difference between that oval here and this one? Yeah, there is a kind of a discontinuity if you look at it. So this has tangent that continues everywhere, and you can clearly see that it is as a kind of a discontinuity at this point, to say if you are mathematically inclined. So it is not smooth everywhere, but at the start and end we can say that when you combine, you do not have the tangent in the same direction. Are you able to visualize that? Not like in a oval. So how do you make it now? How do you make this as a smooth guy like the other oval? How the control polygon should be? Yeah, like a square. Where do you start? So remember, the curve will pass through B0 and B1. So I will have this B0, then B1. I mean, I don't need to have a square maybe. So something like a square that as he looked at it, right? So some control polygon, so B2, B3 and B4, and then this also has to be there. So what is the issue now? When I want to get a smoothened one very similar shape, now what is that I am doing? How many control points I have here? How many control points I have here? 4. What is the degree of the curve? 3. Now if I want to little bit make it better, now what will happen here? How many control points? I have to go for more control points, and then the degree of the curve becomes little higher. Okay, that is the problem in a Bezier. When I want to have a much more smoother curve, I actually want to have more control. That is actually a disadvantage in a Bezier one, which is incidentally he raised about the closed one, and you can see if you want to have closed one, it can have a little bit of issues when you want to have a smooth curve, and then you have to have more number of control points because of these properties. That is a very good point, but you can see that. Any more questions? Can you speak louder? We can, but then they will have their own control points. You can definitely split it. So that is called as a reparameterization problem. So when I have a curve, like I will give you an example. So when I have a curve, you can see there is an underlying control polygon, okay, something like this. Okay, when I split this guy into two different shapes, let us say I have this as one shape and this as another one, I cannot retain the same control polygon, because remember then this point becomes a end point for another curve. Now the control polygon has to split again, because you remember the last point has to pass through the control, otherwise it cannot go. So you have to split the control polygon also, that is called as a reparameterization problem. So then you will have one control polygon here and remember this is the same tangent coming out, and there will be another control polygon, something like this. Okay, so that is called as a popularly called as a reparameterization problem. That is what we just discussed. Yeah, so that's what we have been discussing, right? So if you have set of collinear points, it depends on the order. Okay, so if you don't have the collinear points, if these points are like this, you know how this control polygon is, and I know how the curve is, correct? The curve will be something like this, and now I flatten it out, the same thing, same order, right? It's a 0, 1, 2, 3, 4. So this is also same order, 0, 1, 2, 3, 4. What will happen now? What is the curve here? It's just a straight line between B0 and, okay, it should be 4, B0 and B4. So it is basically a curve which is something like this. Okay, incidentally in this case it gives the impression that it passes through other control points, but this is a special case on that. Is that okay? It's, ask him, is it okay, answer. But if you change, that is what we discussed, the flipping of the order of control points, B0, B1, B2 to B0, B2, B1. Of course, B1 is there and then to B2, and that is what the collinear case that we discussed. Any other question?
So there are holes in the middle for the collinear case.
Collinear case? No, it's a continuous curve. So if you look at the parametric space, when you draw the curve in the parametric space, if you look at that, there won't be any discontinuity there. It's same as how this curve is, like what you have, this is a continuous curve here is, same thing, you just flatten it out. Any other question? You don't want to ask any tricky question and put me in trouble? Looks like maybe I have asked all the questions and I think exhausted. Suppose you are the teacher for this course and you want to set a question paper, one question on this. So what is your question be? These are all, you have to draw the control polygon and trace it. Yeah. So when this and this coincides in the y axis, let's say it will have slightly different configuration. If not, it will have a little bit different. Same as what we have drawn in this 4-point case, right? You have just extended the same thing there. See, all finally you have done only that. You may think that you have done a very great set of control points, but if you look at whatever we have discussed, it is just little bit variant on that. Right, so B3 is here, B4 is here. So your guy will be like this. So it won't go here and come. So it will touch somewhere here and then it will all go across. So it will be, so a very similar case is what we have drawn here. See, these 4 points is what you have toggled little bit. So what you have in your case, okay, this is like a mirror image on the other side, and you have more control points between B0 and B1 and more control points between B2 and B. Same case you have, if you imagine. Like if you rotate your notebook, you will see it's basically the same case. Right? You can draw that. Question. So you, yeah. So what will be the Bezier curve for a star polygon or star control? So you guys can try out. So now he is the teacher and he is now asking you the question on that. See, the only one good thing in being a teacher is that all I have to do is to ask questions, whether I don't know the answer or not. Doesn't matter. Okay, of course I need to know, because when I want to correct the answer sheets, that will be a problem. But just asking question, I don't have to really know the answer. So maybe some of you could try that. I think it's not working very well in this laptop. So many of you who have Windows system, it should be much more doable. I think this Windows system of course is there, but there is some issue on that. So if you go there, okay, so if you go to okay, you just type on this one Gershon dot it's in Technion Israel web page. So ac.il, technion.ac.il tells you that it's an an institution, Technion institution in Israel, and then you just put /tilde Gershon, or you can just directly go to Google and search for GUIRIT. It's called GUIRIT, typically GU IRIT. Basically, it's a graphical user interface of what he has an IRIT, which I will try to demo sometime in the afternoon session. It is a little tricky. I think some of the CS guys should be able to pick it up reasonably okay. So, other guys may have some difficulties, but this is only a graphical user interface. Where is the plus here? Okay. So, are you guys able to see this page? So, if you go here at the top, okay, which is the website address. So, if you go to www.cs.technion. This is TECHNION. Incidentally, this is also called as IIT, except that it is an Israel Institute of Technology, not an Indian Institute of Technology. They also call it as IIT, so we can remember it better. So, I was working with him for his postdoc, one of the fascinating guys that I have ever met, even though he was my Guruji for my postdoc. Staunch computer coding guy, is on computer science. He is from Utah there. So, whatever this thing is a complete open source on IRIT. So, if I just open it, so there is a page in this thing, same thing cs.technion.ac.il. It goes in. Okay, if I go here /IRIT, you have everything coming out. So, this is an IRIT geometric kernel. You can see this IRIT modeling environment. This is a completely done on C, complete open source. You can pick the entire set of code from there, completely open source. So, if you go down here, you can so you can just get your own copy. So, if you click on here, it will download the entire set of C files. So, I have contributed maybe one file or two in some 1000 files on this one. So, the entire thing you can compile as a open source for you also. So, if you are a little bit tricky, so we will not probably go deeper into that, but I will show you some demo of this in my laptop in the afternoon. So, in between that, if you just go to bottom, you can see a GUIRIT page here. So, if you go here, it will go to the GUIRIT page, this page actually, and so you can do a manual, okay, not fully one, automatic installation. If you are on a Windows, you click on this exe file. If you are on a Mac, you can click on this package file. Mac, it does not work well, that is why I have switched to the other laptop. It works well in the older Mac and iMac, but in the newer one, because of high resolution, there is some issue on that. I will show you how the behavior is in my system. In this particular one, it is not really behaving well. So, if you just put on that, you will have basically this is the graphical user interface for the IRIT modeling system. Okay, that is what you will have, and you will see that this entire screen should come up. So, you will be able to see this. If you have used some packages or some 3D softwares, this might be little familiar for you. This kind of GUI, like in some of you told what SolidWorks or Fusion, not exactly of that order, but something like that. So, all of you guys are able to install this thing on your system, yes or no, coming up. Okay, so if you go there, you click on those curves here at the top tab. There is a tab on curves. You can see geometry and then curves, surfaces, all that. So, if you go and click on that, you can see the Bezier there. Are you able to see the Bezier? So, if you go and click on that, and then you come to this mouse barrier and use the control key and then left mouse button key. Are you all there or no? Does not matter. Okay, I will just show it. We will probably do more in the afternoon. So, I just pick the control points. You can see the Bezier curve coming up. So, of course, between 2 points, what is the Bezier curve? Is a line connecting the 2 points. Now, if I add one more point, you see the curve, right? Now, B0, B1, B2. Now, I am adding one more point. Will it pass through B2? No, you can see that. So, I added B3 and you can see that it passes only B2 and B3 and I can keep on doing it, okay, you can see that. So, this is kind of a GUI graphical user interface and nicely you can try out all these guys. So, let us look at the question of that star, right. So, whether we will see my answer is correct or not. So, I am unnecessarily putting myself under test, but let us see. So, I hope I can give a decent star. Okay, Bezier, it does not click. Okay. Now, let us say look at a star shape. The curve is possibly visible and you can see that it has followed the control polygon shape. So, you can see that it starts here. Okay, mine was not exactly matching the control point which I can match it locally, but you can see that the curve goes like that and comes back, which is what I think some of you tried. So, you can see that it is somewhat narrow than what you are maybe you may be thinking it goes like this, goes all the way, goes comes and then rounds. I think I do not know why it is not happening. Something explaining becomes little difficult. Yeah, it is not going in the directions, you are right. I also thought it will, but it appears that it is not completely going around it. It is probably trying something in that direction, but it is not fully going into that. I think the other control points are stopping it from reaching too far. That is what is happening. Yeah, so that is fascinating, but you could try this. In fact, one thing I want to show is to use that control and shift which is not working and then pick a control point. So, lines which pass through the, which one you are talking about? Oh, we do not have a control polygon in shape other than straight lines for this input. So, the Bezier control polygon is always a straight line polygon. That is actually good thinking. Maybe we could like a C to C++, we could come up with a Bezier ++ and we can see whether we can have a control polygon that is not straight. So, what I want to show, I think it is not happening, but if any of you guys are there, what I want to show is that I want to move one control point which is already there and show how the behavior of the curve is, which is not happening. Let me try again. So, this is fairly clear to understand when we have one control point, second, third, fourth, fifth, 6, we can see all this 7, 8. Now, we can see the curve is getting narrower and narrower. So, 8, 9, 10, 11, 12. Yeah, so you can see that it is kind of getting flattened out, like it is not exactly like it is going to follow completely all the control polygon. It is kind of getting flattened out somewhere, and you can see even though we have so many control points, the curve probably the only property in Bezier is that the curve does not oscillate more than the control polygon. That does not mean it can oscillate less than the control polygon. Okay, I think apparently it does less, much lesser than the control polygon is. What I want to show, if you guys have that, if you press control and shift, it should pick one of the control points, and then if I move, the curve should move. This is it happening? Other guys? So, then you can see how the behavior of the curve is when I move one control point. I think which I am unable to show, I will just delete every guy here. Is that I want to show here. Mac it's not even happening. So, go pick that. So, what I want to do, just have 3-4 control points, maybe 4. Okay. Already. This is fairly okay, but I just want to pick. So it's picking, but somehow it is not exactly tagging with this and then moving it. So for example, if you want to pick this point, Control Shift. Okay, so let us delete all. I think yeah, it's working great. So I'll just pick that Bezier here. Okay, and then let's put some control points. Okay, we can see the curve starts coming out. Okay, now you guys observe. Okay, you just look at the curve is that, and you tell me your observations. So I am just picking the middle control point, so to speak. Oh, control and shift. How did you? Oh, okay, okay. I think there is some issue. Okay, I had to redo again. Out of practice is a problem. So you can see how the curve nicely follows the control point and all other properties. What does the key use? Control and shift. Really picking. Yeah. So now we can see if I just move that control point, what are the things you could observe? I am moving the control point all over the place. Remember, I have not moved any other control point. I am moving only one control point, but what is that you can observe? The whole curve gets changed. Okay. So that is one of the greatest disadvantage of the Bezier curve. So even if I change one control point, you can observe that the entire curve gets dislodged. Okay, this is actually one of the fundamental issues in the Bezier curve, and good that this laptop is, I don't know, the same thing got picked and there it was moved. So this is what actually I want to demonstrate that. So you hopefully you guys observe that in your laptop and use the control and shift key. So one of the major issues in the Bezier curve is that even if you change one control point, the entire curve changes. That means there is no local control. Like remember, if you want to design your aircraft or your chassis, or so suppose if I change one point, imagine that every other points also get so we will see that the entire shape gets affected, which you do not want, right. You want to have a nice shape, but locally we need to preserve that, and globally you should not make a change also. This is one of the fundamental difficulties in the Bezier curve, which we will see how we can overcome in the case of a B-spline on that. So the one another question that might be of interest. Okay, suppose let us say you have a parabola, simpler question. So what is the equation of a parabola? Leave out the parametric form and all, just simple. Y equal to x square. So can you draw that in your notebook quickly? So leave out the laptop now, but ensure that you do something on that. So let us change it to my. You want to take your laptop or can it be here? Yeah, you are not going to use too much on that. So